Hi, everyone. I'm Artur Bergman, founder and CTO of Fastly. And it's 2025, and connectors are still not working well. So I founded Fastly in 2011. It's an honor to be here. I have been an open source developer for a very, very long time. I started off in open source of the Perl 5 core team in the previous century, and has ever since been involved in a lot of different open source projects, products, and events. And in 2011, I started Fastly, where we make the internet a better place. All experiences are fast, safe, and engaging. And so, what is Fastly? We are a network around the world with servers that sit between users and the central cloud locations, providing a whole bunch of services. And you're like, Artur, this is a really boring marketing slide. And I'll be like, that's true, just wait. What we actually are, right, is we have about 100 locations around the world. These locations all have physical servers. I understand today a lot of software developers have actually never been in a data center, which, lucky you. But we still have plenty of them. And as someone who's benefited immensely from open source, and I think to really kind of explain more what we do to this audience, we have a program called Fast Forward, where we sponsor all these wonderful projects with hosting. So essentially, whenever you download a software package on the internet, it probably comes from a Fastly service. I have some quotes here from 3 of the different projects that use us. And this is something we're immensely proud of to be able to offer. Because we've, as a company and as individuals, me, the founding team, and everyone else, has benefited immensely from the infrastructure. So we serve, at peak today, about 1 million requests per second of open source software packages around the world. And it's so when your build systems are fast because they're pulling content really fast, like that's us. Also, when you watch lots of live streams, VOD, surf the web, buy stuff online, that's also us. But for this audience and for me, I think this part of the business is really important. So we started 2011. And we started with 5 POPs, 5 locations, a couple of servers, and a fairly small network. Now the network peaks at 40 million requests per second, probably, and total network capacity is about 400, little over 400 terabits per second worldwide. And that's been a long journey of learning in how to operate at scale. But also learning that I wasn't, if you asked me 14 years ago that becoming a platform that our customers rely on was a separate parallel journey, because it's one thing to just build, a scalable system. It's a different thing to build a scalable system that other people are building scalable systems on. And so I wanted to talk about platform, and this talk will diverge a little from, I think, a normal technical talk. So I have kind of always thought about platforms, but it wasn't until about a year ago that it kind of clicked for me how to really describe what a platform is, because there's a lot of different ways to describe it. And I kind of came to it more from it's kind of more an emotional description of what a platform is. So I don't know if, I'm in Europe, so more people probably know what Festival is than in the US. But that's my daughter, and I got all into Festool, so I dressed her as Festool as well. Festool is a German power tool brand that has helped me define what I think of platforms. So bear with me. Festool is 100-year-old, and they're famous for something called dust extractors. Dust extractors is what normal human beings would call vacuum cleaners, but they are certified to deal with lead, blah, 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 blah. These are very, very good vacuum cleaners. And amazingly enough, cost about as much as a Dyson. So I think either these are vastly underpriced, or the Dysons are pretty overpriced. But it's just a vacuum. They also invented, it's kind of funny, this was invented in 1982, the straight rail. Before that, straight rails did not exist, apparently. And it turns out that making a 2-meter rail straight and shipping it is a really hard, physical engineering problem, but they invented these. And they invented this, which is kind of looks like a boring container, storage container. They also invented a circular saw, which a table saw is a saw you slide material over, a circular saw is a saw you slide material on. The reason I discovered Festool is because I live in, by US standards, a relatively old house, 100. I need to do some work, and I asked my co-founder, Tyler, what saw to get, and he said, get the Festool one, it's the best one. And then I talked to someone else who said, you should not get it. It is the best, but it's the most expensive. Turns out it is not the most expensive at all. If you really go into that world, there's more. And of course, I'm a nerd, so I was like, this looks cool, I'm going to get it. Kind of a mistake. Ended up being a lot more than just one saw. So how do these things fit together? Well, these containers stack on the vacuum cleaner, which until you have to drag stuff around, you're like, why is that a big deal? It is a big deal. You only have 2 hands. This rail, obviously the saw runs on the rail, right? Makes sense. Why wouldn't it? The rail also has a hole in it so that you can put it on top of the sustainer, so you can carry the rail and the sustainer with one hand. It's like these small details. This is a router, not like the router we know. There is some overlap in these terms, router, bits, etc., even though they're completely different worlds. The router runs on rails. In fact, I think as far as I can tell, if they sell something that could plausibly run on one of these rails, it does. They have a chainsaw that runs on the rail. It's pretty cool. These then stack. So you can now stack your sustainers high, and each piece of equipment you buy comes in one of these sustainers, so you add on more. And what you see here is a vacuum cleaner in the shape of one of these sustainers. So you can now stack them even higher and buy more of them. They have a battery system. This is the standard base platform that most tool companies will talk about. They'll talk about a battery system, which is just that they have proprietary connectors. They actually added Bluetooth to their batteries, which initially I was like, really? Bluetooth works even worse than HDMI. But their Bluetooth has talks to the dust extractor, aka fancy vacuum, so that it turns off and on the vacuum when you turn the power tool on and off. It also notifies you when you leave your batteries behind, which I have friends in the trade who tells me that's an important feature because they lose a lot of money by batteries wandering off. And if you haven't ever bought any of these tools, the batteries cost generally more than the tools, or at least equal. They also innovated quite significantly. This is the Festool Domino, which was released about 20 years ago. Patent's about to expire. People are very excited because now otherwise people may do it. It basically takes mortising, which is making holes in wood to put it together, much easier. I don't use it very often, but if you're a furniture maker, you're going to use it a lot. And it saved a lot of time. And they patented it. They integrated it with their dust extraction, and the rest of the world has been complaining they're not allowed to do it. They also, so they have a culture of innovating patents and then building that into a platform. So you end up with these stacks. And the power of this is that once you have one of these tools, right, you want to buy more. And they use that to such effect that in the US, they released this Independence Day sustainer, which is just one of these boxes with a branded iron for your steak that says Festool, a salt shaker, a pepper shaker, and an apron for $189. And it's sold out immediately. So to me, it's like, okay, that's what Germans think Americans will buy. And then it turns out they're right. That is exactly what Americans will buy. They also have like some ridiculous things like this, which is a hand sanding block connected to the dust extractor. So I think like at some point, like you can't get to make a product there unless you integrate with the dust extractor. This is a spirit level. It's the best spirit level I ever used. But the really cool part is that it slides into the handle of the sustainer. And I really wonder, like, did some engineer go like, ooh, there's a hole in the sustainer we could slip the thing in? Or did they go like, if we make it this way, we can then make a spirit lever to slide in? I really want to ask them this question, actually. When you buy the tools, they come with like all the insets and little displays that tell you where everything goes. Also helpfully reminds you of the things you didn't buy because you were too cheap, so that you can then go and buy them and like fill out your collection. But very useful because everything has its, its place. And so this is a 100-year-old power tool company. And if you think about like true platform plays, to me, there aren't that many. And now I'm going to define like how I view platform. Is if I am a user of a platform and that platform provides a new product or service or function that I need, will I just use it because I already know the platform, right? Like if Apple releases another headphone, I'll probably just buy it because I know it'll work with my iPhone. Do they make the best headphones? Probably not. I haven't even looked the last 10 years. I just know that I won't have the like Bluetooth shit if I buy someone else's, right? In the real world, I think Lego is a great platform play. They started off having like 1,000 different products. They went down to Lego. Twice they went away from the brick. Twice they nearly went bankrupt. And in fact, my 11-year-old was just complaining because he bought, I think, like Lego Play, and the characters are like larger, so they don't fit with normal Lego things. And he was very mad because he couldn't put it in the others. So they broke the perception that all Lego works together. And so when we think of this as how we design like our products or platforms, and we provide, at every level, the notion is your platform provides a promise, right? Whatever that promise is. And when you add new features, new functionality to your platform product, it has to live within that promise. And if you break that promise, your users will get sad, confused, annoyed, angry. So Fastly has these, kind of corresponding to those. I compare dust extraction to network, right? Like when it works, no one cares. When it doesn't, there's shit everywhere. Same with your network. So there's some things that like silently are part of it. Some of more, there. But if you do something that doesn't match what your customers want, they get upset. Other way of looking at it is like if I need a tool that they make, I buy it. If they don't make it, and they don't make that many, I spend like 3 hours on YouTube watching reviews, because no one actually writes anymore, and then I have to buy the tool and hope it works. And the end result of that is that like, if you are a platform customer or a platform user, platform does it, why do you go for that thing that already exists? Well, because you get value quicker, right? Like you already know the ecosystem, you know the tooling, you know the lingo, you know all of it. So the cognitive overhead of the act of adopting a new thing is much lower if it fits into the platform, right? And this is kind of, I think this is more of maybe a philosophical definition of platform, but over the last 2 years I've really shifted my way to thinking about it. And I think it applies, from very low level all the way up, because core of it is this promise, right? Promise of what you deliver. Tell you, like they sell a angle grinder that doesn't do dust extraction. I bought it, and man, I was pissed for like a weekend when I realized that it doesn't. And even worse, they license it from another manufacturer, and that manufacturer has dust extraction on their angle grinder. So some product manager at Festool was like, screw it, we're going to ignore all of it and just do it easy. And this is hard, right? Because you have to think about like global maxima versus local maxima. Right? Like it's easy to optimize in the moment and forget that then you break this great promise. That was the detour. Hope it was useful. That's the set of a platform. Another big, important lesson of Fastly for me is outliers. We spend a lot of time on outliers. We spend a lot of time looking at data and performance. This one is pretty cool. This is the latency to our POPs around the world. So this chart, this started with an empty map, and the dots are just drawn based on latency. And you can see no one lives in the US Midwest. For example, no one lives in central South America. North Korea does not exist. South Korea is an island. There are also some other pretty cool things, like here you can see the Nile. There's a lot of people that live next to the Nile. So we dig into data a lot. And we spend a lot of time looking at metrics. And like, where do you start with metrics? And I'll just cut to the chase. Like, you should never look at medians, right? Let's just always look at 99th percentile or higher at scale. And this is an example of a thing that we were debugging. And if you look, I don't know if you can see that really closely, but that is the 6.9p, which at like 40 million requests per second happens 40 times a second. So it's like, yes, not that often, but pretty often still. And what we found is that by looking for these, you can actually usually improve the entire system. So we spend a lot of time on this. So in this case, there was some things that shouldn't be done inside an event loop, let's say, that was being done, that unnecessarily sometimes slowed down the event loop by accidentally doing file I/O. We fixed it, and you can see the latency histogram. But the latency histogram actually dropped even for the lower nines. So 4 nines, 5 nines, and 6 nines. And then, you do a control, and you roll back, and you see if it fixed it. And then you quickly roll it out to everyone. So the top number there is about 80 milliseconds, and the 4.9 one, I think, is about 5 milliseconds. So for most users, like, they're going to notice. But as we've developed a culture of really looking at outliers. Like, you find outliers, they're not something, you don't ignore them because they're outliers. Like, you go after them because they're outliers. Because the outliers is also what your most sophisticated and technical savvy customers will find, or users will find, and then complain about. And then they'll, you then have to fix them anyway. So it's just become really part of our culture. And I think I rarely look at anything below P99, but really rarely on anything. It's probably some damage of the scale, but P999. And I'm running a little over because of the delays. So the other thing that really learned from the Fastly years is to focus on outcome. Like, keep in mind, like, what is important? Like, why are we doing this? What is your user trying to achieve? What is your customer trying to achieve? And are we doing the thing that will help them do that better? Or are we needlessly innovating on something that we shouldn't? And there's a lot of needless, unnecessary innovation in this world. I'm staying at a hotel where the room key is like half-sized. And every time I lose it in my pocket and my wallet, I go like, some person spent time innovating on this room key to the detriment of all hotel guests. They could have spent it on innovating on anything else. There's a lot of that going on. And that leads me to this word, which is a terrible word, and some general, I think, career advice to anyone, which is never say something should be fixed because of technical debt. Because it can at best mean, well, in the best case, it means what it means, which is the cost of maintaining this code is higher than the benefit of maintaining it is. In most cases, it means, I don't like this code. Or sometimes it means, I really want to rewrite it in this new shiny language or this new shiny thing, because that's what I want to do. And so I've kind of banned anyone from telling me something should be fixed just because this, like, actually have to specify, is it credit card debt or is it like a good mortgage? Like one of them is bad, one of them is not bad. Doesn't automatically make it bad. And that is in context of outcome, right? Because the operational value of code is based on the time in prod of code. So if your code has been running in prod for a year and your new code has never been running in prod, the value of the code is in the old code. Doesn't mean that the new code won't replace that value pretty quickly, but at that moment in time, the value is the opposite. And the longer the new code is not in prod, the longer it is until it realizes any value, and therefore will probably never realize value. And so then this goes to another thing that we focus a lot on at Fastly, which is how to prevent global outages, which you then reframe as how do you cause a global outage? And so how do you cause a global outage? It requires a global state change. And what is a state change? Well, it's a software release or a config release or a workload. Now, workload is a little bit out of, as a platform provider, right? Like workload is a little bit out of our hand, like customers could choose to do something different, shift vast quantities of traffic to us, different forms. But code and config, those are definitely things that we control. And I think one of the lessons we have learned is that there really isn't a difference between code and config. If the code is out there for a year but hasn't been run because the config is off, and then you flip the config, and it's really the same thing as pushing the code. And so you should just think of them as the same. And so, you know, if your blast radius of your change is global, you have to stop and think. There are very few things that actually have to be a global immediate state change. And from a networking point of view, there is one that's like unavoidable, which is anything to do with BGP routing is instantly global, nearly instantly, but most others. Yeah. Also at scale, there's no lab or dev in the world that will help. So these are some of our rules. They're not super hard. But they have no fast rolls, but fast recovery. And then every known instance of crash in a canary production must trigger investigation immediately. Like you can't let any of it slide. The one that I think is the most important is the rapid rollback, whether that is config or code. And ideally, automated rapid rollback. Maintain situational awareness when timing production advantage. We had an outage once in a POP, where so our POPs have 4 networks in them. There's 4 switches. All machines are connected to all 4 networks. All internet is connected to all 4 switches. Middle of the night, someone is doing a software update on the switches. The first switch goes offline. Second switch goes offline. The third switch goes offline. And then they do the 4th switch and the POP goes offline because they never checked that the other switches had come back. And so when you're doing any of these critical changes, like maintaining situational awareness is important. And then to end, I wanted to share something. I a little more, but we've been. I'm old. I view this LLM stuff somewhat dubiously, but we found that we have found a lot of value in feeding all of our incidents through history into LLMs and training them on that. And it's so if you haven't played with that, I can highly recommend that. We now have the ability to classify, get much better, much faster recollection of previous incidents, and also getting summaries. So this is we sent this out to customers, but this is a pretty good summary of a very, very, very long investigation covering many Zoom calls and many chats and many log files and many things. And it's been a very significant help as the network has grown larger than any person's ability to keep it in their head. So I can very much recommend this. Like, trying to use these tools on your own data to analyze any form of incidents. And especially incidents that didn't lead to like full-on outages, because you're not really. So in the air safety world, right, you treat near incidents as failures, and I think in our world we tend to keep, operations, we tend to treat near failures as successes. We try really hard not to, but it's like human nature. But you don't have as much time to debug them, talk about them, and these tools have been very, very helpful in allowing us to investigate these near failures more like we would any other, like a failure that actually occurred. The final kind of rule I have is that the abstractions are key. You have to understand, a little bit underneath you, a little bit above you. You need to get the abstractions, right? And do people here know what the Winchester Mystery House is? I see some hands. Okay, it's in San Jose, South San Francisco. If you have an architecture team and they are in that area, send them on a group event to the Winchester Mystery House. This is an image from it. This woman built it over like 50 years without any plan. And there are doors going into walls, going into windows. It is like amazing. And it's an example of what happens when you don't plan ahead, when you don't have abstractions, and it's a great team building and exercise for any enterprise architecture team for sure. Highly recommend that. But with that, thank you so much.